Alright, section 2 deals with conservation of energy and with potential energy and kinetic energy and how they relate to one another. This is going to be a really short video because I just want to show you an example dealing with collisions and how we can calculate out like information from there. And since chapter 11 is really small, what I'm going to do, just kind of give you a heads up as you're listening to this, I am not going to be giving you an assessment over chapter 11. I kind of think they should have just had chapter 11 go into chapter 10 since it is all dealing with energy. That's my opinion. So on to the example. So in an accident on a slippery road, a compact car with a mass of 575 kilograms moving at 15 meters per second smashes into the rear end of a car with a mass of 1575 kilograms moving at 5 meters per second in the same direction. Okay, so A. What is the final velocity if the wrecked cars lock together? Okay, so to figure out the final velocity, what we're going to do is we are going to use the conservation of momentum. Now, if you kind of remember momentum, mass times velocity, and it is represented with a P. So if we take momentum of car A plus momentum of car B initially, that should be equal to the momentum of car A final plus momentum of car B final. So let's kind of put our information into here. So car A is our compact car that has the mass of 575 kilograms and is moving at a velocity of 15 meters per second. Car B, that's the 1575 kilogram one, and its velocity is 5 meters per second. Now, for the final, since the cars are locked together, their final velocity is going to be the same thing. And what we're just going to have to do is add the masses. And find our final velocity from there. So our final velocity is going to be equal to 575 kilograms, 15 meters per second plus 1575 kilograms times 5 meters per second. And that's going to be all over 575 kilograms plus 1575 kilograms. Okay, so 575 times 15 plus 1575 times 5 all over 575 plus 1575. I'm coming up with a final velocity of 7.67 meters per second. B. How much kinetic energy was lost in the collision? So what we need to figure out is what is our kinetic energy at the beginning and what is our kinetic energy at the end. Alright, so our initial kinetic energy, what we're going to have to do is take the kinetic energy of car A plus the kinetic energy of car B. Well, kinetic energy, 1/2 times mass velocity squared. So for car A, 1/2 times 575 kilograms times 15 meters per second squared plus 1/2 1575 kilograms times 5 meters per second. Okay, so 1/2 times 575 times, actually let me put all this into one parentheses, plus 1/2 1575 times 5 squared. I'm coming up with 84,375 Newton or joules for an answer. Now, for our final kinetic energy, we already have our final velocity, and since they are still considered to be together, our masses times our final velocity, and that's going to be squared. So 1/2 times 575 plus 1575 times 7.67 squared, and I'm coming up with 63,241 joules. So now with our two kinetic energies, what we're going to do is we're going to find our change in kinetic energy. So that would be taking our final kinetic energy minus our initial kinetic energy. So 63,241 joules minus 84,375 joules. And we're going to come up with 63,241 minus 84,375, negative 21,134 joules. So that's our answer for B. Now C, what fraction of the original kinetic energy was lost? So to find that, we're going to take our change in kinetic energy over our initial kinetic energy. Okay, so negative 21,134 joules over our initial, which was the 84,375 joules. So negative 21,134 divided by 84,375. So I'm coming up with a negative 0.250. And if we multiply by 100 just to get a percent, because that will kind of help us out, coming up with right around 25% of the original energy is lost. Okay, so I hope this will help you out with the assignment for Chapter 11. If you have any questions, please email me, and I will talk to you later. Thank you.